Hello students, welcome to Shri Classes, lecture number 2, chapter number 3, pair of linear equations in two variables. We'll continue the lecture. Last time I discussed about consistent pair of linear equations in two variables, inconsistent pair of linear equations in two variables. Now let me list down the behavior of lines and the existence of solutions. What I mean by behavior of lines is, are these intersecting, coincident or parallel lines? This table you must note down, and that should be noted down in 180 pages notebook. And let's see here. These are the two given pair of linear equations, one pair of linear equations, and graphical representation. If the two equations represent intersecting lines, then algebraically they must have unique solution. Pair of linear equations are said to be consistent pair. Is it clear? If the graphs are coincident lines, they have infinitely many solutions. Such pair of linear equations are called dependent pair of linear equations in two variables or consistent pair of linear equations. If the lines represented by these two equations are parallel, there is no solution for such lines, and the equations are called inconsistent pair of linear equations in two variables. You can have a look at this once again. I think you are able to understand this. Graphically, if the lines are intersecting, they will have a unique solution, and we call those pair of linear equations as consistent. If coincident lines are there, they will have infinitely large number of solutions called dependent pair or consistent pair of linear equations. Similarly, if the graphs are parallel lines, then there exists no solution for the same and called inconsistent pair of linear equations. Now, if I ask you a question, like I will give you a pair of linear equations, would you be able to tell whether those are consistent or inconsistent without plotting the graph? May not be possible, isn't it? Because you have to plot the graphs and then you should be able to confirm whether those are consistent or inconsistent based upon intersecting, non-intersecting or coincident lines. But dear students, you must appreciate a fact that taking the ratios of coefficients of the two linear equations, we would be able to conclude whether the graphs are intersecting lines, coincident lines or parallel lines. I hope you are understanding. See, for a given pair of linear equations, if the ratios of coefficients are a1 by a2 is not equal to b1 by b2, then we can definitely conclude the lines represented by the two equations would be intersecting lines. Conversely, if there are intersecting lines, this ratio holds true. Similarly, for coincident lines, for infinitely many solutions, what would be the ratio of coefficients of linear equations? For this case here, it is a1 by a2 equals b1 by b2 equals c1 by c2. For coincident lines, if we take the ratios of the two equations, you find that a1 by a2 equals b1 by b2 equals c1 by c2. For parallel lines where no solutions exist, the ratio would be a1 by a2 equals b1 by b2 is not equal to c1 by c2. You must note it down. Here, if the lines are intersecting, this ratio holds true. For a given pair of linear equations, if this ratio holds true, conversely, the lines represented are intersecting. If the lines are coincident, this ratio holds true. Conversely, if this ratio is true, then the lines are coincident lines. For parallel lines, this ratio holds true. Similarly, if this ratio holds true, conversely, the linear equations representing the lines are parallel lines. So the converse is also true here. I hope you understand here. Now, I'll take a few examples and see, based on the ratios of coefficients, whether we will be able to conclude whether the graphs are intersecting, parallel or coincident. Okay. You must note down this in your 180 pages notebook. You can take a screenshot or you can pause the video for noting down. Yeah, I hope you have noted down already. Okay, let me erase this and I'll take some examples to illustrate this. Let's take this example here. X plus 3y equals 6. 2x minus 3y equals 12. The question over here, whether these two equations represent intersecting lines, coincident lines or parallel lines. Let us conclude the same by taking the ratios of coefficients of these two linear equations. Dear students, very important aspect over here. Before we populate the values of A1, B1, C1 and A2, B2, C2, you must express the given pair of linear equations in a standard form. Otherwise, there could be a possibility of taking the wrong values for A1, B1, C1. I hope you understand. Let's see. Writing these equations in a standard form, x plus 3y minus 6 equals 0, 2x minus 3y minus 12 equals 0. I am transposing. Comparing the first equation with a1x plus b1y plus c1 equals 0, I can conclude a1 equals 1, b1 equals 3 and c1 equals minus 6. Note the negative sign, c1 equals minus 6. Similarly, comparing the second equations with a2x plus b2y plus c2 equals 0, I can populate the values of coefficient of x, that is a2 equals 2, b2 equals minus 3 and c2 equals minus 12. Note down the negative signs for the values, important. Now let me take the ratios. a1 by a2 equals 1 by 2, simplified. b1 by b2 equals 3 over minus 3, which equals minus 1. Yeah, these two information is enough for me to conclude that a1 by a2 is not equal to b1 by b2. Here, as a1 by a2 is not equal to b1 by b2, what would be my conclusion? I can conclude that the lines are intersecting. Lines are intersecting. First part. Second part, algebraically, what does it represent? Unique solutions. Algebraically, for intersecting lines, there is a unique solution, and also you can conclude one more thing, whether these are consistent or inconsistent, and the pair of linear equations are consistent. Consistent pair of linear equations. This is how we can conclude taking the ratios of coefficients. Let me take the second example. Second example, x plus 2y equals 1300, x equals 1300 minus 3y. These equations are not in the standard form. Let me convert them to standard form, populate the values of a1, b1, c1, a2, b2, c2 and then take the ratios. By converting into writing in the standard form, I get x plus 2y minus 1300 equals 0, x plus 3y minus 1300 equals 0. Compare these equations, both the equations, with general form of equations and populate the values of a1, b1, c1 and a2, b2, c2. So from this, a1 equals 1, coefficient of x, a2 equals 2, coefficient of y, not a2, b1 equals 2 and c1 equals minus 1300, a2 equals 1, b2 equals 3 and c2 equals minus 1300. Note the signs important. Let me take the ratios now. a1 by a2 equals 1, b1 by b2 equals 2 by 3. Do I need to take the third ratio c1 by c2? Not really, because I know a1 by e2 is not equal to b1 by b2. Hence I can conclude the lines are intersecting with unique solutions and consistent pair. Therefore, as a1 by e2 is not equal to b1 by b2, the lines are intersecting unique solution and consistent pair of linear equations. Consistent pair. Is it easier? Yes, it is quite easier and quite interesting also. That by taking the ratios of coefficients, we should be able to conclude that the lines are intersecting parallel or coincident. How to confirm this? Is there a confirmation over here? No. So my request would be, you plot the graphs for the given equations, these two equations, and check whether these are consistent, unique solutions, intersecting, same intersecting, unique solution, consistent. You can check that by plotting the graphs. Let me take one more example, third example. Nine x plus 3y equals minus 12. And 18x plus 24, 18x plus 24y equals, no, 18x plus 24 equals minus 6y. Are these in standard form? No. Let me write this into a standard form. Nine x plus 3y plus 12 equals 0, 18x plus 6y, transpose it, plus 24 equals 0. Comparing with standard general form of equations, a1 equals 9, b1 equals 3, c1 equals 12, a2 equals 18, b2 equals 6, c2 equals 24. Now take the ratios. a1 by a2 equals 9 by 18, which is 1 by 2. b1 by b2 equals 3 by 6, which is 1 by 2. a1 by b2 equals b1 by b2. I must take the third ratio also, without which I would not be able to conclude, because only for these two cases, if I check, I may end up with coincident lines or parallel lines. Please go and check the conditions in terms of coefficients. So let me take the third ratio also, that is C1 by C2. C1 by C2 equals 12 by 24, which is 1 by 2. So what would be your conclusion? Can you guess, please? Here I can write as A1 by E2 equals B1 by B2 equals C1 by C2. My conclusion would be the given pair of linear equations. What kind of lines? Parallel lines represent coincident lines, sorry. Coincident lines. How many number of solutions? Infinitely many solutions. Infinitely many solutions. And are these consistent? Yes, consistent pair. The other word for coincident lines is dependent pair of linear equations or consistent pair. Dependent pair, or it is also called consistent pair. How did you conclude that these are coincident and dependent pair? By taking the ratios of A1 by A2, B1 by B2, C1 by C2. From here I can conclude that all these ratios are equal. These equal ratios represent lines with infinitely many solutions, and the name for those is dependent pair or consistent pair of linear equations. Have you observed one peculiarity of this here, these two equations? What do you conclude? Here, if I take a common for this, 6 is a common, 3x plus y, 6 I will be taking, 3x, just a moment, 9x, 6. Okay. Let me take common over here. 6 as a common. 3x plus y plus 4 equals 0. Equally, if I take a common over here, what would be common? 3 over here, which is 3x plus y plus 4 equals 0. So you will appreciate over here that these two equations are same. Means I can say these two equations are equivalent equations. Are you able to understand? These two equations, after simplification, we are arriving at the same equation. Is it not? And hence, these two equations are called equivalent equations, which are equal to each other. And for equivalent equations, always the lines are coincident with infinitely many solutions, and the name is dependent pair or consistent pair. With this, let me take few numericals from the textbook, exercise 3.1. Probably about 3 sums are there. Let me illustrate. Let me take one sum, and we will plot the graph also. So we look into exercise 3.1. Okay. I hope you have understood up till now. Note down. Yeah, fine. You can look at here exercise 3.1. Exercise 3.1. Dear students, remember while solving these exercises, make sure you switch over your notebook to 400 pages hardbound notebook, because 180 pages we have kept it only for conceptual writing. Only the concepts and the main formula will be there. Whereas while for solving the numericals and all, you can switch over to 400 hardbound notebook, 400 pages hardbound notebook. Okay, fine. Exercise 3.1. Aftab tells his daughter, 7 years ago, I was 7 times as old as you were then. Also 3 years from now, I shall be 3 times as old as you will be. Represent this situation algebraically and graphically. What would be your answer? What can you guess? Represent the situation algebraically and graphically. Algebraic representation involves formation of algebraic expressions. Graphical representation involves plotting up of a graph. I hope you are able to understand. Algebraic representation is the formation of linear equations in two variables. Graphical representation is plotting up of a graph. Okay, fine. So you refer your textbook now, open the exercise 3.1 and the first problem, and let's see how to solve this question. Okay, fine. So in the question you have seen, Aftab tells his daughter, 7 years ago I was 7 times as old as you were then. Also 3 years from now I shall be 3 times as old as you will be. Here I have to consider Aftab's age and his daughter's age to be the variables. So let Aftab's present age be x years, daughter's present age, present age be y years. 7 years ago, Aftab's age equals present age is 7 years ago x minus 7. Daughter's age present age y 7 years ago x minus y minus 7. According to question, 7 years ago Aftab's age is how many times? Aftab's age is 7 times his daughter's age. According to question, Aftab's age is 7 times his daughter's age. So according to question, x minus 7 equals 7 times y minus 7. Let me check it. Yeah. 7 years ago, I was 7 times as old as you were then. Yes, it is correct. Solve it. 7y minus 49. X minus 7y equals minus 49 plus 7. Transposing. X minus 7y equals minus 49 plus 7 minus 42. This is equation number 1. Second situation, he says, the question says, 3 years from now, Aftab says, I shall be 3 times as old as you will be. 3 years from now means after 3 years. After 3 years, if the present age of Aftab is x, after 3 years, x plus 3. Aftab's age, x plus 3. Daughter's age, y plus 3, because y is the present age of daughter. After 3 years, y plus 3. According to question, again, according to question, Aftab says, I shall be 3 times as old as you will be. Aftab says, x plus 3 should be equal to 3 times y plus 3. I hope you are able to understand here. Aftab's age is 3 times the age of starter. Okay, therefore, simplify x plus 3 equals 3y plus 9, x minus 3y equals 9 minus 3, transposing x minus 3y equals 6. This is second equation. X minus 3y equals 6. We have arrived at these two equations. Question is, represent the situation algebraically and graphically. Therefore, algebraic representation. What is algebraic representation? Linear equations in two variables. Those are equation number x minus 7y equals minus 42 and x minus 3y equals 6. These are the algebraic representations. What about graphical representations? Graphical representations, we have to plot this graph. I am writing these two equations on the top and I will plot the graph. See how to plot the graph also. I think you can note it down. Yeah, I hope you have noted it down. So what are the two equations we have now? X minus 7y equals minus 42, x minus 3y equals 6. Fine. Let me erase and try to plot the graph now. The given equations are, first one, x minus, see now I'm going to discuss the graphical representation. Graphical representation. The meaning is plotting of graph. Plot the graphs. Equations are x minus 7y equals minus 42. Express y in terms of x. 7y equals x minus x plus 42. Y equals x plus 42 divided by 7. This is the expressing y in terms of x. Prepare the truth table. X and y. In last lecture I had told you, while plotting the graphs, if we can obtain the values in terms of intercepts, only 2 points are enough to plot the graphs. Just a very small introduction for intercepts of the graphs. Say for example, in a graph, a line intersects x-axis and y-axis at these points. Here P1 and P2. This is the graph of some linear equation. This is called the x-intercept. And this portion is called y-intercept. I hope you will be able to understand this. What is the meaning of x-intercept? X-axis is intercepting the graph at this point. What is y-intercept? Y-axis is intercepting the graph at this point. X-coordinate here, x-coordinate of this point P1 represents x-intercept. Y-coordinate of this point P2 represents y-intercept. So this much distance, this distance is x-intercept and this distance is y-intercept. I hope you understand this. Let us prepare the truth table for this. as much as possible, if I can obtain the values in terms of intercept, it is better. I said let x is equal to 0. So 0 plus 42 divided by 7, which is 6. Let me take minus 42. We can plot the graph still. Minus 42, 0 divided by 7, 0. These 2 points are enough for me to plot the graphs. Let's see. I think I can erase this part. Before we plot, let me prepare the truth table for the next equation also. The other equation is x minus 3y equals 6. X minus 3y equals 6. So 3y equals x minus 6, y equals x minus 6 divided by 3 here. Truth table x, y. Here let me take x equals 0, minus 6 divided by 3, minus 2, and x equals 6. 6 minus 6 is 0 by 3, 0. Yeah, these two are enough for me to plot the graphs. Let us plot the graph here. Exercise number. This is exercise 3.1, first numerical. Okay. Let's plot this graph. X dash, y dash. We have to take the scale here. See, the range is 0 to 42. So x axis 1 centimeter is equal to 6 units. Similarly, y axis 1 centimeter equals 6 units. Okay, let's see. Similarly, minus 6, minus 12, 18, 24, minus 30, minus 36, minus 42. Here, minus 6, minus 12, minus 18, minus 24, minus 30, minus 36, minus 42. Yeah, this is the graph paper. Now, let me plot these points. Before I plot, let me name these points also. Let this be P1, P2, or make it A1, A2, B1, B2, which is better. This is A1, A2, B1, B2, and definitely distinguish between the points. So A1 will be 0, 6, A2 is 0, 6, and A2 is minus 42, 0. Similarly, B1 is 0, minus 2, and B2 is 6, 0. Let me plot this on the graph. 0, 6. 0, 6 is this one. 0 is x coordinate and y is this one. minus 42 comma 0 minus 42 x quantity this one. Probably I can take one more, or let me check if I can take one more. Just a moment. So if I take 42, what happens? 42, 84. 84 divided by 7. 7 ones is 7 twos, which is 12 for this. So the third point, which is A3, 42 comma 12. 42 comma 12. So 42 comma 12. Here this is something like this. It is not up to the scale, but anyway, yeah. So I have 3 points which I will be able to join by a straight line. This is the graph for first linear equation. Let me name that also. X minus 7y equals minus 42. This is x minus 7y equals minus 42. This I have to highlight it. 0 comma minus 2, 0 comma minus 2. This is 0 minus 2. 6 is over here, so you can approximately 2 plus 2, 4. 1/3 of this one approximately I can plot here. And probably you can take some other points also, so that now the scale is not allowing me to take minus 2 on the x-axis, but I can approximately take over here, or I can take the other values also. Next is 6 comma 0, 6 comma 0, x is 6, y is 0. Let me take another 1 or 2 points. 1 point, let me check on that. 42, if I take 42, what will get? 42 minus 6, 36. 42 minus 6, 36. 3 ones are 3 twos are. Here also I will get 42 comma 12. This is B3. 42 comma 12. Yeah. Let me plot this also. 42 comma 12. Already this point is over here, so it should pass through this way. Yeah. Not good looking graph, because you can plot on the graph paper to get it very neatly. Okay. So this is the equation. This equation is x minus 3y equals 6. X minus 3y equals 6. Yeah, this is how it is. So, how to plot the graph once again? Take the linear equations. After forming the linear equations, express y in terms of x, prepare the truth table, take the suitable points, suitable scales, and plot it on the graph. We concluded, and let's see, let me apply taking the ratios of coefficients, whether it will give me the intersecting lines or not. That also we'll just try to see. I can take the ratios over here. Before I take the ratios, both the equations must be expressed in standard form or a general form. So let me see. The two equations are x minus 7y equals minus 42. So x minus 7y plus 42 equals 0. The other equation is x minus 3y equals 6. X minus 3y minus 6 equals 0. So these two are in the standard form. What are the A1, B1, C1? A1 equals 1, B1 equals minus 7, C1 equals 42, A2 1, B2 is minus 3, C2 minus 6. Take the ratios A1 by A2, Here I can solve. A1 by A2 is 1. B1 by B2 equals minus 7 by minus 3 minus 7 by minus 3, which is 7 by 3, implies A1 by A2 is not equal to B1 by B2. The meaning, you can read the ratios of this nature in the first table that I had displayed. You can conclude from this that the two lines represented by these equations are intersecting and with unique solutions. What is the solution for these two lines? Unique solution exists over here. Can you see the point of intersection of these two graphs? What are the coordinates of this? B3 as well as A3. 42, 12 is the common point for both. Therefore, the solution of the pair of linear equations represented by these two, x minus 7y equals minus 42 and x minus 3y equals 6. The solution is 42, 12. 42, 12. This is the solution for this. I hope you understand the graphical as well as algebra. Now, for the algebraic verification, if I substitute these x and y values in the LHS of the equations, definitely you can check both LHS and RHS would be equal. So algebraically also this is the solution, and graphically also this is the solution. I think you have understood this one. Okay. Let me take another two examples. I will form the equations only, and you have to plot the graphs at home and check whether those are consistent or inconsistent and what are the solutions of those graphs. Okay. Very quickly we will take the examples, and the two examples. You can by the time you can have a look at the exercise 3.1, second and third problem. Yeah, here the coach of a cricket team buys 3 bats and 6 balls for rupees 3,900. Later she buys another bat and 3 more balls of the same kind for rupees 1,300. Represent this situation algebraically and geometrically. Algebraic representation is formation of linear equations, and geometrical representation is plotting up of a graph. Let's see here itself. A coach of a cricket team buys 3 bats and 6 balls for how many rupees? 3,900. What are the variables? The number of bats and balls has been given. The total amount is in rupees. Therefore, let the cost of each bat be rupees X. The cost of each ball be rupees 6. Are you able to understand? The cost of each bat is rupees X. The cost of each ball is rupees Y. 3 bats, 3x. 6 balls, 6y. 3 bats, 3x plus 6 balls, 6y equals 3,900. This is one of the linear equations. Next, later she buys another bat and add 3 more balls of the same kind for rupees 1,300. We already assumed that x be the cost of each bat. So one more bat, x. Y be the cost of each ball. 3 more balls, 3y. X plus 3y together 1,300. Are you able to understand? These are the linear equations for this. You can represent it graphically by plotting the graphs. Next situation. The cost of 2 kg of apples and 1 kg of grapes on a day was found to be rupees 160. After a month, the cost of 4 kg of apples and 2 kg of grapes is 300. Represent the situation algebraically and geometrically. We need to form a pair of linear equations, which is the algebraic representation, and plotting up of a graph is the geometrical representation. So, cost of 2 kg apples and 1 kg apples on a day. Here, the cost of 2 kg of apples and 1 kg of grapes on a day was found to be rupees 160. Here, quantity of apples and grapes is given. Cost is not given. Let the cost of 1 kg of apples be X. Let the cost of 1 kg of grapes be y. Therefore, 2 kg apples 2x plus 1 kg grapes 1 times y equals rupees 160. Similarly, the cost of 1 kg of apple is x, therefore 4 kg is equal to 4x rupees. The cost of 1 kg of grapes is y, therefore 2 kg grapes is 2y. 4x plus 2y equals 300. 2x plus y equals 160. 4x plus 2y equals 300. I have told you verbally over here. Think over and you can plot the graph to get the graphical solution. Remember students, generally the variables that need to be assigned depends upon the way the question is asked. Here of course the question is only the algebraic and geometrical representation, but in further classes generally the variables are assigned based on the way the question is asked. Okay, anyway, that I'll discuss when I saw exercise 3.2. Okay, for the time being, I think you can note down all these things. For you, the first assignment is exercise 3.1. You have to do this, complete this assignment and submit in 2 days. If any doubts, you can reach back to me. Okay, fine. Thank you. Wait for the next lecture. Thanks a lot.